All right, so what we're gonna do is that you're gonna do a quick bell ringer using Edpuzzle, which is what you're using right now, and you're gonna have some questions embedded in what we're doing at this time throughout the video. Okay, so our assignment for today is what the bell ringer is, not the assignment itself, but how to approach it. Okay, so you notice that there's two already done for you, but I'm going to go ahead and explain how to go about doing this so that you know exactly what to do, because this is where it gets most students when you start mixing ionic and covalent. So the very first thing I'm going to ask you is to write this down. If your first element is a metal, then that means that compound is ionic, and you use the ion sheet, which is this one. If your first element is a nonmetal, that means it's a covalent compound, and what you're going to do is use the prefixes. As long as you remember that, or you always look at this, then you're going to be okay. So take a look at the first one. Okay, so the first one says sodium carbonate. Okay, so the very first question is your first element a metal or non-metal? On a periodic table, you have this line, and that line, it borders the metalloids. So it separates the metals from the non-metals, but you have some elements called metalloids in there. Just remember, if it's on the left, they're metals. If it's on the right, it's non-metals. Hydrogen happens to be the only one that's going to be a non-metal on this side, and that's because it has one valence electron. Okay, so looking at sodium, sodium is right here, so therefore it's a metal. So it's ionic. So again, because it is a metal, our compound happens to be ionic. So we're going to use the ion sheet. Okay, first thing you want to do is you want to cut it out. Cut it in half. Keep one element on the left and the rest of them, whether it's 1, 2, or 3, on the right. So in this case, we have 2 elements. Okay, so if we look at our ion sheet, take a look at the first one. So look up CO3 or anything close to CO3, and that one is carbonate. So we know that the name for the first one is carbonate. If we look up sodium, which I already said what it is, but it'll tell you that it's sodium. Put those two words together, and it's sodium carbonate. So that would be our first answer, as you can see. Okay? For the next one, P2O5. Okay, so you first have to look at your first element, just like you did before. Is phosphorus a metal or a non-metal? There it is. So it's on the right hand side with the non-metals. Because it's a non-metal, is a compound ionic or covalent? It's covalent, because the first word is a non-metal. Okay, split it in half, but this time, because it's covalent, we use the prefixes. Those. Okay, we know that 2 means di, 5 means penta, the letter P is for the element phosphorus, and the letter O is for oxygen. So what we have right now is diphosphorus, because the prefixes go first, pentaoxygen. But the second word is not right. First of all, the ending for the second word should always end in "ide." And whenever you have oxide, you have to drop the vowel from the prefix. So in this case, A. So it becomes pentoxide. So our word here is diphosphorus pentoxide. So take a look at another example like 21. Tetraphosphorus triselenide. What if they give us the name and they're asking us to find the formula? So in this case, I see that there's prefixes, so I know automatically that it's covalent. Although if I look at phosphorus, the first word, phosphorus is a nonmetal, so I know it's covalent as well, looking at that. So we know tetra means 4, tri means 3. Phosphorus, the symbol is P. For selenide, it comes from the word selenium, or the element selenium. And then the symbol for selenium is Se. So we put it together, and it gives us P4, Se3. And that would be the formula for that one. Okay, another example would be 22, potassium acetate. So looking at potassium, we know it doesn't have prefixes. We know potassium, which is K, is a metal, so it's ionic. We look on the ion sheet. Potassium, there it is. It's K, positive 1. We look up acetate. There's acetate, C2H3O2, negative 1, which is where I got that. You're going to put them together because this is the same amount in charges. They cancel each other out, and this is our final formula. Okay, that's how you're going to do today's assignment. If you have any questions, let me know.